A new paper published in the journal Communications, Earth and Environment discusses the discovery of a lost branch of the Nile River that ran close to the Giza pyramids. Over the years, archaeological finds have supported the hypothesis that royal pyramids were connected to harbour complexes. However, 31 pyramids belonging to the Old and Middle Kingdoms are not close to the Nile River or any other water source. A lot of research has been done in the past to identify extinct water channels in Egypt and to also see how the Nile's course has changed over the millennia, but this had yet to fully explain the location of 31 pyramids in the desert, including those at Giza. This new study provides a convincing explanation for why the ancient Egyptians built their pyramid complexes between Lisht and Giza where they did. Before we look at the latest paper, let's take a look at the previous one on the Khufu branch that was published in the Proceedings of the National Academy of Science in 2022 and titled Nile Waterscapes Facilitated the Construction of the Giza Pyramids During the 3rd Millennium BCE. I did a video on this, but I think it's good to summarize it again in light of the latest study. In this article, a team of researchers provided evidence for the existence of a now defunct channel of the Nile that ran close to the pyramids of Giza and may have helped transport limestone blocks to the plateau for their construction. The hypothesis that water may have facilitated construction was not a new one, and various evidence had come to light over the years which supported it. Archaeological findings showed that a paleochannel, as well as harbours and man-made canals, did exist in the area. It's become increasingly clear that Giza was a harbour complex. The papyrus fragments discovered at Wadi al-Jarf on the Red Sea also talk about a harbour complex called Roshi Khufu, which means entrance to the lake or basin of Khufu. This could be referring to an area close to the Great Pyramid. However, environmental evidence has been lacking. The authors of the paper carried out palaeoecological analyses to reconstruct the fluvial history of the Nile close to the Giza pyramids over a period of 8,000 years. They drilled 5 cores in the present floodplain east of the Giza pyramids, the area where the paleo channel now referred to as the Khufu branch would have run, and extracted fossilized pollen grains to build up a picture of ancient water level change in the area. They found that the water level of the Khufu branch had varied over the millennia, with its peaks corresponding with increased anthropogenic activity on its east bank. The water level had dropped significantly by the New Kingdom before the channel became defunct. It's quite possible that this Khufu branch helped in the transportation of limestone blocks to the Giza plateau, and that it was part of a fluvial port complex that supported small boats all year round and larger vessels during the annual flooding of the Nile. Old Kingdom engineers may have had sophisticated hydraulic capabilities that were able to exploit the Khufu branch. The latest paper looks at a defunct branch called Ahramat and the role that it probably played in the decision to construct pyramids west of the Nile. According to the authors, no proper explanation has ever been given for the location of the highest concentration of pyramids in Egypt, which is a narrow strip of desert running from Lisht in the south to Giza in the north. The paper starts off by explaining the climate and environment in Egypt from the early Holocene. So let's summarize that information to begin with. Around 12,000 years ago, the Sahara went through a transformation, changing from an arid desert landscape to a savanna as a result of sea level rise at the end of the last glacial maximum. At that time, known as the African humid period, the Sahara had large rivers and lakes and was more habitable for humans and wildlife than the Nile Valley with its swampy environment. Analyses of fluvial sediment in the eastern Mediterranean basin showed that the Nile River had a high discharge during the African humid period, which ran from 14,500 to 5,000 years ago. Annual rainfall was between 300 and 920 millimeters, and the Nile had multiple channels. During the mid-Holocene, between 10,000 and 6,000 years ago, freshwater marshes were common features of the Nile floodplain and made the desert margins of the valley more hospitable to people. The late Holocene, from 5,500 years ago, saw the humid period end. Precipitation decreased, sedimentation increased along the Nile Valley, and the Sahara became more and more arid. These environmental changes caused the movement of people from the Sahara to the Nile Valley. However, However, the Nile's discharge was much higher than it is today, so multiple branches of it still existed. During the Old Kingdom period, the first pyramid complexes were built on the margins of the Nile floodplain. The ancient Egyptian civilization developed alongside the Nile due to the role it played in agriculture and transportation at a time when the Sahara was no longer hospitable. Experts have long known that the Nile River course has migrated laterally since then, and that multiple branches of it once existed before silting up over the years. Understanding these changes to the Nile River is an important part of determining why certain ancient Egyptian settlements and monuments were located where they were. However, little about these former watercourses is known with any certainty. Previous research has only concentrated on fragmented sections of the Nile Valley system, the Khufu branch discussed earlier being one such study. Much of the ancient Nile floodplain is hidden under sand, silt, or anthropogenic activity. Therefore, it's challenging to investigate it. The authors of the paper used various methods, including remote sensing and soil coring, to provide evidence for the long-lost Ahramat Branch of the Nile. They then used this data to create the first map of the palaeohydrological setting of the area, stretching from Lisht to Giza. Although not visible on an optical satellite image, synthetic aperture radar imagery, radar high-resolution elevation data, and geophysical surveys provide evidence for segments of an ancient river branch that bordered 31 pyramids dating to between the Old Kingdom and Second Intermediate period. This channel lies between 2.5 and 10.25 kilometers west from the modern Nile River. Stretching over 64 kilometers, its depth varied between 2 and 8 meters and its width between 200 and 700 meters. Such a large waterway would have played an important role in the lives of the ancient Egyptians. Some of the segments of the Ahramat Branch are now occupied by the modern Bahr el-Labaini Canal. Over time, the meandering branch migrated eastwards before silting up. The migration would have caused the abandoned channel to form narrow oxbow lakes in its meanders, and these can be seen on historical maps from 1911. It's likely that the Darshur Lake is the last existing part of the Ahramat Branch. Core samples showed that the branch was infilled with sediment different to the surrounding deposits, and that its buried sedimentary structure acted as a conduit for the flow of groundwater beneath the modern floodplain. In ancient Egypt, a royal pyramid usually had a mortuary temple built alongside it, and a valley temple constructed further away, which was reached by a raised ceremonial walkway. It's long been hypothesized that the valley temples were harbour buildings sitting on ancient river channels. Not all of the valley temples have been found, so it's possible that they are buried underneath the sands or agricultural fields that sit along the old Ahramat branch of the Nile. Those that have survived belong to the Bent Pyramid, the Pyramid of Khafra, the Pyramid of Menkaure, the Pyramid of Sahura, and the Pyramid of Pepi II. These all sit alongside the Ahramat branch, which shows that it was a functional river during the Old Kingdom when these pyramid complexes were constructed. Western tributaries of the Ahramat branch were also identified. The causeways of several pyramids lead to the riverbanks of these inlets. One of these is the Bent Pyramid, which is deep into the desert, far from the modern Nile River. Its 700-meter causeway and valley temple do not lead to the bank of the Ahramat branch either. However, they did overlook the extinct inlet of the Ahramat branch, which has now been named the Darshur Inlet. Although no causeway or valley temple have ever been found at the nearby Red Pyramid, it's possible it did have these features originally and that they led to the Darshur Inlet as well. The Middle Kingdom pyramids in this area are located 1 kilometer to the east of the Old Kingdom pyramids, which suggests that the Ahramat branch shifted eastwards with time, something that showed up on the surveys. 6 kilometers north of the Darshur Inlet, another tributary was found close to the ancient city of Memphis. Named the Saqqara Inlet, the causeways of the pyramids of Pepi II and Merenre would have led to its banks. The researchers also found that the causeways of the Khafra, Menkaure, and Khenkaus pyramids on the Giza Plateau would have led to another extinct tributary called the Giza Inlet. At Giza, the causeway of the Khufu pyramid would have led directly to the Ahramat Branch. I think that the location of a lot of ancient monuments can be explained by extinct waterways or springs. In Malta, a study a few years ago found that the Gigantea temples are near a spring caused by a fault, something that had not been identified before. When I was in Sardinia a couple of years ago, I noticed that a menhir I visited was next to an old riverbed. I'm not a geologist, so I could be wrong, but it certainly looked like that. Also, a couple of months ago, I did a video on the Cyclopean building I visited in Cefalù in Sicily. That's definitely not near a water source, but the person that discovered an Egyptian scarab there around 80 years ago talked about finding it near a stream. Apart from the research on the Khufu and Ahramat branches, I haven't read the other studies on the ancient Nile River, but I will take a look at those and perhaps do a video summarizing the whole hydrological story. Thank you for watching, everyone. Please hit the like button if you enjoyed this video. A big special thank you goes out to my patrons and channel members, and I'll see you next time.